Hello student friends, morning all of. I am again Dr. Shaukat before you in a new session with a new subject. The subject what we are going to discuss, the subject under discussion now is your Thiophene. In the last class we had a discussion, thorough discussion on furan, its preparation, properties and applications. Now we are going to discuss Thiophene. Again the same concept, Thiophene, preparation, properties including physical and chemical properties, then applications of Thiophene. Concept is Thiophene. Thiophene formula is C4H4S, and the structure is S here. Same thing exactly like your furan. In the case of furan, the structure in the heterocyclic position there is oxygen, whereas in Thiophene the heterocyclic element here is sulfur. This is again heterocyclic organic compound. The presence of lone pair of electron over the oxygen, that is sulfur in Thiophene, while there is exhibiting aromaticity, it always remain under delocalization, making the Thiophene a stable one, similar to your benzene exhibits as a result, that is thereby exhibits your aromaticity, a unique property associated with your aromatic compounds. Now the concept is Thiophene, its molecular formula is C4H4S. This is your Thiophene. And either you can draw this like this, or as usual, you know very well that how to draw the Thiophene. Simply a circle, a ring inside your Thiophene. Now the next thing is how the Thiophene is prepared in the laboratory. Preparation of Thiophene. Simple thing, take sodium succinate, CH2 COONA plus, CH2 COONA plus. This is your sodium succinate. Up to this succinic acid part, when we have H and H, this is your succinic acid. Since there is sodium substituted, this is your sodium succinate, sodium salt of your succinic acid. This sodium succinate, when treated with, on heating with your phosphorus trisulfide, what we get is your Thiophene CH2 double bond CH2 double bond CH2, yes. Thiophene plus, this is your Thiophene, because the formula is C4H4 and yes, now correct. Thiophene plus and plus sulfur. These are the products we get. Anyway, the final product what we get is Thiophene. The simplest method of making Thiophene is treats the sodium succinate with phosphorus trisulfide. On heating this, you will get Thiophene. This is the method number 1 of making your Thiophene. Another method is simply heating your butane with sulfur at very high temperature CH2, CH2, CH3 and CH3. Butane, treat this with sulfur at 600 degrees Celsius. That is very high temperature. 4 molecules of sulfur is involved. 3H2S plus thiophene. This is the final product, thiophene. Method number 2 is butane. We have methane, ethane, propane and butane. There are 4 carbon containing your compound. Therefore, this is your butane as per IUPAC nomenclature. Butane on treatment with the sulfur gives you at very high temperature around 600 degrees Celsius gives you hydrogen sulfide plus thiophene. These are the 2 different methods we have to prepare your thiophene in the laboratory. Number 1 is sodium succinate when treated with phosphorus trisulfide gives you thiophene. Number 2, butane when treated with sulfur at high temperature gives you thiophene plus hydrogen sulfide. See the board. Have a glance of this whiteboard. Are you clear? Is it legible? Is there any problem in looking this whiteboard? If there is any defect, if there is any problem with you while understanding or while that clarity of the board that I am using, let me know please. I'll try to rectify the defects in my next class. Yes. Now the next thing is regarding your properties of your thiophene. As far as the properties of thiophene is concerned, it's a liquid, exists in liquid state. Its boiling temperature is around 80 degrees Celsius, 80 degrees C, and it resembles exactly it has exactly the odor of your, similar to that of your benzene. It's insoluble in water and freely soluble in most of your organic solvents. I repeat, it's a colorless liquid. Its boiling point is 80 degrees Celsius, resembles close to your benzene in odor because this is also an aromatic compound. Boiling temperature is 80 degrees Celsius, freely soluble in ethanol, ether and acetone, and insoluble in water because this is an aromatic. Naturally, aromatic compounds will not dissolve in your water. And compared to reactivity of this thiophene is little better with respect to reactivity when we compare this with the benzene. As a result, anyway, with respect to chemical property, it resembles exactly with your benzene. That is, the thiophene also undergoes electrophilic aromatic substitution reactions. Benzene undergo the same thing. Therefore, naturally, thiophene should also have to undergo this reaction. This also undergoes very easily. The only difference between thiophene and benzene is benzene require little bit extra, that a conditional atmosphere to carry out the electrophilic substitution reaction like 120 degrees Celsius or 80 degrees Celsius, etc. Whereas here, the temperature is not that much required because of the reactivity of thiophene, which is highly reactive compared to your benzene. At moderate condition itself, thiophene undergo the famous electrophilic substitution reactions like your benzene. Moderate condition is enough to carry out this electrophilic substitution reaction. Now we are going to discuss what are the different types of electrophilic substitution reaction, like we had a discussion when we discussed the chapter namely your furan. Similar to furan, thiophene also undergo nitration reaction. Number 1, nitration of thiophene gives you same product, same position, 2 nitrothiophene. In the case of halogenation, gives you 2 halogen substituted thiophene. Say for example, if the halogen is chlorine, you will get 2-chlorothiophene. Thiophene undergoes sulfonation reaction when the reagent is sulfuric acid concentrated. In that case, the product is thiophene 2-sulfonic acid. Similarly, thiophene also undergo your Friedel-Crafts acylation reaction. When thiophene is treated with acetyl chloride in presence of aluminium chloride as catalyst, you will get that is 2-acetyl thiophene. Position number 2 is getting substituted by your acetyl, that is acyl group CH3CO in the case of your Friedel-Crafts acylation reaction. So these are the few electrophilic substitution reactions normally the thiophene exhibits or shows. Number 1 we are going to discuss. Number 4 is, I'm going to erase this whiteboard. Properties. Chemical properties of your thiophene. Number 1, I'm writing thiophene in the middle so that all the reactions, possible reactions of thiophene we can explain very easily. When thiophene is treated with chlorine, that is halogen, the condition is moderate, you will get yes, 2-chloro, the rest of the thing, nothing but your thiophene. This particular reaction is called halogenation of thiophene or halogenation because you are using halogen. Finally, halogen is getting substituted in your thiophene, therefore this is your electrophilic substitution reaction because you are using Cl plus as electrophile in this halogenation reaction. Therefore, this is halogenation. Right, now come next. The next is when thiophene is treated with sulfuric acid concentrated, you will get SO3H. This product is thiophene 2-sulfonic acid. Position 2, there is sulfonic acid, the SO3H is substituted, therefore this is thiophene 2-sulfonic acid. How to write thiophene 2-sulfonic acid? Thiophene, then 2-sulfonic acid. Next, come next. The next reaction is your nitration. Treat thiophene with nitric acid, the condition is moderate, you will get NO2. This is your, you know very well that this is your thiophene, 2-nitrothiophene. Its name is 2-nitrothiophene. And finally we have one more reaction. That reaction is treat this with acetyl chloride in presence of your aluminium chloride as catalyst. You will get COCH3. This is your nothing but 2-acetyl thiophene. This reaction is famous reaction, namely Friedel-Crafts acylation reaction. Conversion of thiophene into 2-acetyl thiophene is called Friedel-Crafts acylation reaction. See the board? The reactions that is possible with respect to electrophilic substitution reaction possible with respect to thiophenes are thiophene is nothing but number 1 is halogenation, in which you are treating the thiophene with chlorine. The product is 2-chlorothiophene. As I told you, the condition is not that much serious condition is required because thiophene is active compared to your benzene. The first reaction is halogenation, in which you are converting thiophene into 2-chlorothiophene. The second reaction is thiophene when treated with acetyl chloride in presence of aluminium chloride as catalyst. you are getting 2-acetyl thiophene in a reaction called as Friedel-Crafts acylation reaction. Number third, thiophene when treated with concentrated sulfuric acid getting converted into thiophene to sulfonic acid in a reaction, namely sulfonation of thiophene. Finally, thiophene when treated with concentrated nitric acid, it gives you 2-nitrothiophene in a reaction, namely nitration of thiophene. These are the few possible reactions with respect to your thiophene. In the next thing, we have the reaction of 2 more reactions of thiophene. Important reactions are there that we will discuss now. That reaction is called desulfurization. Desulfurization. Reaction is desulfurization. See how I am writing the spelling of sulfurization? Desulfurization. You are removing the sulfur from your thiophene. This is desulfurization. Removal of sulfur from thiophene. What will happen when we remove the sulfur? Naturally, only when there is sulfur in the system, this remains as thiophene. When we remove thiophene, there is sulfur from thiophene, naturally it gets collapsed. Naturally, we will get ultimately a different product that we will see under this topic, desulfurization. For this, you treat the sulfur, that is thiophene, with hydrogen in presence of nickel as catalyst. Nickel as catalyst. On heating this with, you will get CH3, CH2, CH2 and CH3 plus, I think the product is nickel sulfide. This is your butane, aliphatic compound. Thiophene on catalytic reduction. When thiophene is reduced using nickel as catalyst using your hydrogen, thiophene gets reduced into butane, thereby removal of your sulfur takes place. The removed sulfur connects with your nickel, converting the nickel into nickel sulfide in a reaction called desulfurization of thiophene, or simply desulfurization. Desulfurization. Have a look. I'll wait for just in seconds. After that, I'll move my discussion into the next one. Now the topic is reduction of thiophene. This is desulfurization. Now reduction. Thiophene, when reduced with your sodium amalgam, and in presence of ethanol, it will be converted into a compound, namely tetrahydrothiophene. Tetrahydrothiophene. This is where THS, or simply tetrahydrothiophene. Thiophene gets converted into tetrahydrothiophene when thiophene is reduced using sodium amalgam and ethanol. See the board. Yes, friends, with this, I'm concluding my discussion on this particular topic, Thiophene. I hope I have explained thoroughly the concept of Thiophene. What is Thiophene? The structure of Thiophene, the basic formula of Thiophene, its physical properties, chemical properties of Thiophene, desulfurization of Thiophene, how to carry out this desulfurization, reduction reaction of Thiophene using sodium, amalgam and ethanol. Try to follow me carefully, be attentive in the classroom. Try to, replay the video again and again till you understand the concept, please. Because there is no classroom interaction is possible. We are very far. The pandemic, COVID-19 pandemic restricts us to contact in person. Therefore, please be careful. If there is any doubt, you can ask me as usual. I'll try to clarify your doubts. Till then, bye. Thanks for watching my videos. Thank you.